Before continental drift became scientifically accepted, village folks noticed mysterious, strange objects and features on the landscape. Fossils, stones, scars in the land, not realizing they were witnessing the early pieces of what would one day become the geological evidence for plate tectonics. You can imagine what they, as average folks, must have thought about these. In Yorkshire in 1780, a shepherd chips at a pale vein gleaming in the cliff and watches a shard fall. It looks like breath-frozen solid. He mutters that it was ice that never learned how to melt. Far to the south in Devon in 1650, a farmer pauses mid-plow at the sight of sandstone layers slanting like a bed someone had risen from too quickly. He whispers that the land's been turning in its sleep again and steps back as if it might roll over. And in Norfolk in 1710, a villager's weird garden of ammonites and concretions buys a little, well, time.
Greetings, gentlemen. Come to collect a payment, have ye? How out I pay you with a real stone snake? It was slithering, only out an hour ago. That'll scare him off a while.
Centuries later, a scientist would look at the same kinds of clues, not with fear or folklore, but with pattern recognition. And after this imaginative early 20th century scientist started to solve the puzzle of curious coastal shapes on every map, publishing multiple major works, his senior contemporaries mocked his interpretation of his findings. Contemporaries like American geologist Bailey Willis dismissed the idea of continental drift by declaring, if the continents moved, the Earth would wobble like a badly balanced flywheel.
The Earth would wobble like a badly balanced flywheel. Oh my gosh!
The often mocked findings came from a German scientist who dared say plainly what a handful of earlier scientists only alluded to, that the continents can and do move.
To be here, to wonder.
That bold scientist was Alfred Wegener, the man who proposed continental drift despite it being virtually cut out for rejection. So why did so many geologists laugh at Wegener's idea? Fantasy world, sliding mountains, unanchored continents, looking at geology as the mother field. Wegener was working in what you could call its offspring. He was really an outsider, and geology at the time believed that nothing made sense unless all the structures of the Earth were fixed in place. This scientific culture had become mechanism or nothing, meaning that unless you could explain how something happened, your evidence didn't matter. A stance that went beyond normal scientific requirements and became a kind of rigidity. This demand for a mechanism in Wegener's day was unusually strict, and it was applied unevenly. Other sciences accepted pattern-first theories, but geology insisted on mechanism first. So from the start, Wegener wouldn't even get other German geologists to take his side. German geology was especially conservative. Geologists thought in no terms of large things on the move or dynamic processes. They were mostly descriptive, really. They were trying to press the idea of fixed everything even onto anything that hinted at motion, treating motion itself as unscientific.
You see?
This view permeated the scientific fields very deeply through worldview and culture because continental motion was associated with amateurs and cranks, spiritualists, mystics, Victorian adventurers, and speculative natural philosophers. Spiritualists in the late 1800s and early 1900s believed the Earth had subtle energies that shifted beneath human consciousness, mountains rising or falling with vibrational changes, continents drifting because of astral tides or planetary alignments. Geological change to them was moral or spiritual evolution. So if you mentioned moving continents in a serious geology department, You risked sounding like someone who thought the Earth was rearranging itself to send humanity a message.
The depth of that chasm is almost unfathomable. Unimaginable, but think of the lost civilizations we could unearth.
Victorian adventurers, the explorers, travel writers, and gentleman naturalists loved dramatic theories. Continents tearing apart in ancient cataclysms, lost land bridges connecting every shore, vanished empires swallowed by shifting seas. They weren't scientists. They were storytellers with compasses, good boots, and a sense of big wonder. Their books sold well. Their ideas were imaginative, and geologists hated being confused with them. Speculative natural philosophers treated motion as cosmic theory. They offered grand explanations: Earth expanding, Earth contracting, continents floating on universal ether, mountains rising as the planet cooled like a drying apple. They weren't doing field work. They were doing armchair cosmology, and geologists wanted nothing to do with that reputation either. And Wegener's idea about continental drift relied on his own healthy imagination. So, imagination isn't necessarily the enemy of science. In science, a healthy, realistic imagination is pretty much a requirement for growing out of ideas so stiff that they're bound to fail. Geologists in 1900 were desperate to distance themselves from that kind of imagination, even if it came from someone as well-educated as Wegener. They wanted to be hard, empirical, mechanistic scientists. Anything that smelled like big, sweeping theory, especially one involving motion, felt to these rigid earthers like a regression. The respectable order of things.
This is the theory of geosinclines. The crust sinks, and then the mountains are formed by the squeezing of the rocks.
At the time, the reigning explanation for Earth's great structures was something called geosyncline theory, a fixed Earth model that treated mountains as the result of wrinkles formed when the planet slowly sagged or buckled. It sounded authoritative, but it didn't allow for any horizontal motion mechanism. It was a limiting story, but the best they had. But it turns out mountains form by horizontal compression, not vertical sagging. This kind of fixed Earth thinking was tied to scientific respectability, with stable continents supporting predictable strata, measurable ages, clear classifications, and tidy maps. And motion threatened the entire intellectual order. Motion required mechanisms they didn't have, making it feel like fantasy.
Saying that the world hasn't always looked like a puzzle.
And it contradicted the emotional worldview of geology, which saw itself as chronicling an ancient permanence. So horizontal motion in the Earth felt chaotic and undignified. Yes, undignified. Flat silly.
Mine! I told you this was a natural lollipop field.
You'll hand that over at once.
Not unless you admit the continents do drift.
Never. That claim's flat undignified. Just go eat your lollipop.
Any talk of continental motion was seen as unserious, speculative, unprofessional, disruptive, and dangerously imaginative. They didn't have mechanisms for continental motion or horizontal motion. Wegener had overwhelming evidence for continental motion. But because he lacked a mechanism, geologists dismissed the evidence entirely. When it came to explaining how geological features got there, geologists relied on descriptive labels that sounded mechanical, but weren't. These words were treated as if they were complete mechanisms, but they were really just names, elegant placeholders that didn't describe any actual forces or motion. Although somewhere in an alternate reality, they actually knew this.
These terms, uplift, subdescents, are not mechanisms. They are simply the names we give to the observed effects.
But back in this reality, geologists didn't teach that they actually had no complete mechanisms for their ideas. Geologists had a partial vertical mechanism. Wegener had a partial horizontal idea, but it was an idea that almost no one in geology cared to develop, because horizontal motion didn't fit their fixed Earth worldview. But how did Wegener stumble on the idea of continental drift? Behold, a frieze adrift. Wegener used his beautiful, educated imagination. He didn't discover continental drift in a single moment. His first Greenland expedition in 1906 gave him a mental model of motion, ice sheets creeping across the land. Then, between expeditions, he began noticing patterns in fossils, rocks, and ancient climates scattered across continents that literally weren't speaking to each other. By his second expedition, in 1912, the idea had taken shape. And across 4 expeditions in all, he kept refining it, carrying the question with him into the Arctic wind. He saw firsthand that huge surfaces can move without shattering, a quiet, physical truth that settled into him as a subconscious template. Then, back in Germany in 1910, he was looking at a world map when the coastlines caught his eye. South America curved inward exactly where Africa curved outward, like 2 puzzle pieces that had once been pressed together. Others had noticed this resemblance before, but treated it as a cartographic coincidence. Wegener didn't. He had just come from a world where enormous surfaces drifted, cracked, and sheared. So when he saw those matching coastlines, he didn't see coincidence. He saw a pattern waiting to be explained. Continental drift was the idea, plate tectonics was the proof. Wegener saw the continents move, but plate tectonics finally explained how. Global-minded. Our trusty meteorologist, by the way, held a doctorate in astronomy, but his heart was never in the observatory. Almost as soon as he earned the degree, he drifted toward the fields he truly loved: meteorology, climatology, and geophysics.
It's fascinating. Yet, of all its planets, only one may I see, touch, and explore directly. This planet, the very Earth.
He joined the Aeronautical Observatory in Lindenberg to study air masses and atmospheric physics, launched weather balloons, and eventually carried those interests into the Arctic, where ice, wind, and the physical behavior of the planet became his real laboratory. Astronomy gave him credentials. The atmosphere and the Earth gave him purpose. He was not a real geologist, however. Yet for his purposes, he was apparently even better. Wegener was trained to think globally because meteorology is inherently global, and that gave him an advantage over geologists who thought locally. But while Wegener was being laughed out of rooms for suggesting continents might move, geologists around the world were making big, impressive, respectable discoveries.
Soon these facts will arrive in the future. They'll be astonished.
But all of them were discoveries that fit neatly inside a fixed, unmoving Earth. They gathered the right facts and wrapped them in the wrong story. And when plate tectonics arrived, the story finally caught up to the facts. Humanity might still be mystified by earthquakes, tsunamis, and volcanoes without Wegener's scientific, cross-discipline imagination. You might say that Wegener, who died while working in the Arctic, was the geological missing link between the great minds of the era. And between those minds and the strange things regular folks witnessed, like big, strange formations that looked like they'd been dropped on the shore from another world. Turns out even they were on to, well, something. Imagining horizontal motion, science taboo of the era. Every era of science has carried its own taboos. Ideas that were unthinkable, embarrassing, or professionally dangerous until new evidence made them obvious. It's been a recurring pattern in the history of knowledge and scientific imagination.
Unacceptable.
That's what happened with motion in geology, and versions of this have happened in every era. In the 1600s, the idea that the Earth moves around the sun was taboo because it resembled mystical sun worship and contradicted scripture. In the 1700s, the idea that lightning was electricity sounded like magical thinking. In the 1800s, germs causing disease resembled folk beliefs about invisible spirits. In the early 1900s, moving continents sounded like spiritualism and speculative adventuring. And in the 2000s, neuroplasticity, which includes how the brain can adapt after injuries by rerouting function, sounded too much like simple self-help optimism. The pattern is always the same. A field builds its identity around a worldview, right? Then a new idea threatens that worldview. The idea resembles something culturally unscientific. The field rejects it to protect its dignity. Then evidence accumulates, the taboo collapses, and the idea becomes obvious in hindsight. Wegener sits squarely in the middle of this pattern. It was a field allergic to motion, a culture terrified of sounding mystical, a scientist whose imagination was multidisciplined rather than wild, and a theory rejected not on evidence, but on sheer identity. Alfred Wegener's rejected clarity is a universal scientific story wearing a geological coat, summed up in one clean line. Every era of science has its taboos, ideas that feel embarrassing, unprofessional, or too close to superstition. In Wegener's time, the taboo was motion.
Young man, you fool! These are mistitled as taboo. Have you not read them with wonder and curiosity? They're taboo!
Jules Wegener? Well, sort of. Jules Verne had mechanisms and Wegener didn't, but they used the same kind of imagination, evidence-based, grounded, and unembarrassed by wonder. He didn't predict the future so much as imagine within the boundaries of real physics and engineering, pushing one step beyond what was known. And Wegener crossed boundaries, but he didn't abandon science. And Verne's wonder? That's exactly the kind of imagination Wegener used. Not mystical, not reckless, but grounded, structured, and bold enough to see what others were too rigid to see. He pulled evidence from everywhere: geology, paleontology, meteorology, oceanography, and ancient climate data. He stitched these fragments into a picture of Earth that didn't exist in textbooks or atlases. That's imagination. Not the whimsical kind, but the scientific kind. We could say that Wegener had the curiosity of a Victorian adventurer, the pattern recognition of a mystic, and the spirit of a natural philosopher. But the mind of a scientist. We're taught to think critically, but imagination is unofficial, not in the syllabus, yet essential to discovery. Sometimes it takes incorporating just a little bit of what resembles science fiction to reveal otherwise unimaginable science. Humanity moves forward when we let wonder chime softly. Wonder and imagination are not the enemies of science. They are actually the parts that help us to remember what we, as a species, risk forgetting when we recognize only rigid science, but not the other half of who we are. Half measures like this fail us every time, but as whole humans, well-rounded, we move forward more steadily. Because somewhere, sometime, whatever we have imagined has an application. It contributes to humanity, if even not directly to science. So there's nothing to lose, except rigidity. And Wegener was more than comfortable with including his healthy imagination in his pursuit of a real contribution. One I like to interpret this way: if continents behave in ways people didn't expect, then what other stories of the human scientific journey are not closed books, but leave much yet to be discovered?